Good morning.
Morning, sir.
Good morning, sir. We'll start our session very soon, sir.
Hello, sir. Welcome.
Welcome, Mama.
Hello. Iqbal, sir. Good morning.
Yeah, good, thank you. Good morning.
How are you?
Fine, thank
So long
you.
days looking nicely.
It is almost afternoon here.
Yeah. Okay. Oh, afternoon.
Almost noon. Yeah.
What time in Indonesia now?
Now it is 11:40.
Acha. Okay.
11:40.
Morning. In the morning.
Yeah.
11:40. Delay.
How are you there?
Yeah, sir. I am also nice here. And with this, our colleague Dr. Rati sir is also in online. He is welcoming to you.
No problem.
Yeah. How department, family members at home?
Yeah, we almost finalized the paper of business May
Okay, examines.
2026. Yeah. Then we have one. So the paper will be published in
Okay,
uh,
yes.
IAP
IEP, yeah.
of proceeding.
Uh,
It is Scopus Index.
okay, in future, have any scope for collaborative work? We have that instrument, linear reciprocating thermometer for testing materials, composite materials, in our PRC laboratory.
I see.
We have that instrument near about 35 lakhs.
Oh,
Actual condition is there, linear reciprocating thermometer. If anybody is your guys, research scholar, we can do the work collaboratively. No issue.
okay. Okay, I will see. But actually, I am interested in to test the tribology testing for
Okay, yeah, we
natural
have that
composite.
tribological test. Pinound is
Yeah.
means linear as well as uh, sliding means circular.
Oh, very good. You
And we have
remember
actual
we
condition instrument. No,
previously we have one paper that we published in this conference
okay.
regarding the tribology of this carbon
Yeah.
composite, yeah, carbon fiber
Yes.
composite. Uh, so in my university I developed a natural composite from banana fiber.
Yeah. I have
Banana
seen your
fiber.
work.
Yeah, so we have some publication also. Yeah, I have
Hello.
publication with you also this regarding this banana fiber.
Vicky.
Okay, sir. Mhm.
Because was video.
Lavanya sir.
Yes, sir. Yes, sir.
तो शुरू करा मग आता.
Sir. Within
Yes,
5 minutes we'll start, sir.
yes.
So please wait for 5 minutes. We'll start, sir.
How is it the university now
Yeah.
running university?
University now currently INSEM examination is going on in
Oh,
next week.
same. Yeah.
Yeah, and after one at the end of April there will be final exam.
April.
Now,
Oh, you start early. We just start.
yeah,
Now
yeah.
we are in the 4 week or 5th week, I think. I
Oh,
see. How many
shortly
weeks we
we'll
have in
go
one
to
semester? In one semester, how many weeks we have? 16, 14, 12,
60/40.
14.
Yeah.
Oh, 14. Okay. Yeah.
Loni sir, may
Yes, sir.
audible?
Yes, sir. So shall I start, sir?
Yes, yes.
Yes.
Thank you, sir. Good morning to all of you, respected chief patrons, honorable dignitaries, keynote speaker, distinguished guests, faculty members, researchers, dear students, and all participants. A very warm morning to everyone. It is my great honor and privilege to welcome you all to the second online international conference on emerging technologies in engineering, organized by Padma Shri Dr. Vikhe Patil Institute of Technology and Engineering Polytechnic Loni. Dear participants, first and foremost, I would like to express our sincere gratitude to our respected Chief Patron, Honorable Sri Radhakrishnaji Vikhe Patil, who is a Minister Water Resources, Godavari and Krishna Valley Development Corporation, Government of Maharashtra, and Chairman of Lok Nete Dr. Balasaheb Vikhe Patil, Padma Bhushan Awardee, Pravara Rural Education Society, Pravara. Dear participants, I would like to extend my gratitude to our patrons, Honorable Sau Shailendai Vikhe Patil, ex-president and member, Jilla Parishad Ahilanagar. Honorable Dr. Syiah Vikhe Patil, BJP Vice President of Maharashtra State and ex-member of Parliament, Ahilanagar Lok Sabha. Honorable Dr. Sushmita Vikhe Patil, CEO, Pravara Rural Education Society, Loni, and Honorable Dr. Shivanand Hirmat, Additional CEO, Pravara Rural Education Society. Dear participants, I would like to extend a special welcome to our today's keynote speaker, Dr. I.R. Mohd Iqbal, MT, Associate Professor, Department of Mechanical and Industrial Engineering Faculty of Engineering, Syiah University, Indonesia. Welcome you, sir. I would like to convey my deepest gratitude to our International Advisory Committee members, Dr. Mohammad Hussain Reddy, Associate Professor, Mechanical Department, Engineering College, Wasit University, Dr. Sachin Chote, Modern Construction, Democratic Republic of the Congo, Africa, Dr. Madhav Chavan, Assistant Professor, Faculty of Science, University of Ostrava, Czech Republic, and Professor Hudda bin A. Majid, Communication and Computer Engineering, University, Tun Hussein on Malaysia, Johor, Malaysia. Dear participants, I also express my deepest gratitude to our National Advisory Committee members, Dr. S.Y. Gue, HOD, Chemical Engineering, Jawaharlal Nehru Engineering College, MGM University, Chhatrapati Sambhajinagar, Dr. Sampat Mandre, Associate Professor, BITS Pilani, Goa, and Technical Advisor, GPCB. Dr. L.B. Abang, Associate Professor, Mechanical Department, Pravara Rural Engineering College, Loni. Dr. Sachin Mule, Professor, Sandeep University, Nashik. Dr. Sachin K. Korde, HOD, Information Technology Department, Pravara Nagar, Engineering College, Loni. And Dr. P.C. Varule, Assistant Professor, ANTC Department, Pravara Rural Engineering College, Loni. Dear participants, I would like to extend a special welcome to all participants and presenters for this second international conference. And I would like to welcome from the bottom of heart our principal, Dr. V.R. Rati sir, and extend my gratitude for his continuous support. Dear participants, the second international conference is organized with the objective of bringing together researchers, academicians, industry experts, and students from the different parts of the world on a common platform to share their knowledge, innovation, ideas, innovative ideas, and research finding in the field of emerging technologies in engineering. Dear participants, please actively engage the session, share your ideas, and make the most of this academic gathering. With this word, I once again welcome you all and wish the ICT 2026 International Conference great success. Thank you, one and all. Thank you. Now, I request to our respected principal, sir, Dr. V.R. Rati, sir, please address this conference. Rati, sir, please, sir. Hello? Hello?
Hello.
I'm audible, sir. Please, sir, address the conference. Rati, sir.
Oh, okay. Thank you very much. Thank you very much, Mr. Chairman.
Hello, Rati, sir.
Yeah.
Rati, sir, our principal, sir, please address the conference, sir. I request all Rati, sir, to address the conference. Hello? Am I audible? Hello, Rati, sir. Hello? Am I audible, Rati, sir? Hello, sir. I request to principal, sir, Dr. V.R. Rati, please address the conference. Am I audible, sir?
Hello,
Rati, sir?
may I audible? Loni, sir?
Yes, sir, yes, sir. Please,
Loni,
please
sir, may
address
I
the
audible?
conference, sir. Yes, sir.
Yes, sir. You are audible.
Loni, sir?
Yes, sir. Hello, Rati, sir. Am I audible? Hello?
Good morning to all.
Thank you.
On behalf of Loknath Dr. Bahasa Vikhe Patil, Padma Bhushan awardee, Pravara Rural Education Society, I welcome you all. The International Advisory Committee, National Advisory Committee, and our coordinators of the conference. First of all, I will be very much thankful to our chairman, Honorable Dr. Radhakrishna Vikhe Patil, Irrigation Minister, Government of Maharashtra, Honorable So Sharanidai Vikhe Patil, ex-president, Jilla Parishad Ahilyanagar, our young dynamic leader, Honorable Dr. Sujay Dada Vikhe Patil. He is a vice president of BJP and ex-member of Parliament, Ahilyanagar, and our motivator, our CEO Madam, Honorable Dr. Sushmita Vikhe Patil. So our management is always keen to develop and give the motivation to our faculty members to organize such type of events. Though our institution is situated in the rural background, I will be welcome to Dr. Mohd Iqbal, Faculty of Engineering from the Indonesia, for his kind support and guidance, and also sparing his valuable time for our international conference ICET 2026. Friends, I have gone through I want to suggest something, that I have gone through the abstracts because I am from the civil engineering background. So I have gone through the abstract of the civil engineering papers and also the other papers which are having the bind volume by our coordinator Professor Lavande sir, and I have gone through that. Only one thing I have to suggest for the young researchers, that in the abstract I find the one deficiency, that whatever work you have done, that work either it may be experimental, either it may be a software oriented, or it may be a case study. Whatever output you have got, that output, whatever it may be experimental or any other kind of work you have done, output of that work should be written in brief, so that the persons who are going through the abstract books, he will get the idea about what exactly the researchers has done. Because this is a very good platform nowadays, and the young researchers will get the idea and some good suggestions through these conferences that how to improve their work, how to correlate the results with the validation point. Either it may be software oriented, either it may be a mathematical modeling, simulation. All these things they can do when they present the paper in the conference. Definitely, the whatever the keynote speakers or whatever the session chairs are there, they will give you some positive feedback of that your research work, and that will be helpful for you in your upcoming research. So once again, I will be thankful to the our organizing committee and all the researchers for getting their keen interest in the conference. Thank you. Thank you very much.
Thank you, sir. Thank you very much. Now, dear participants, now it's time to listen to today's expert talk by Dr. Mohd Iqbal, MD, Associate Professor, Department of Mechanical and Industrial Engineering, Faculty of Engineering, Syiah Kuala University, Indonesia. Dear participants, I extend a warm welcome once again to our today's speaker, Dr. Mohd Iqbal. Welcome you, sir. Welcome, welcome, welcome for the second international conference. Dear participants, I am very happy to tell you about our today's speaker. He has completed his PhD in manufacturing engineering from Malaysia. He has completed his Masters of Engineering in Design and Manufacturing Engineering from Indonesia. He has completed his Bachelor of Engineering in Mechanical Engineering from Indonesia. He has technical skill like virtual manufacturing, production simulation, PLC programming and simulation, and CAD-CAM, including CNC programming and MasterCAM. He has a member of 6 different professional bodies. He has teaching permits in Malaysia as well as in Indonesia. He has supervised 5 PhD students, 25 master students, 12 international students from France, and 200 bachelor students. Dear participants, he has done 13 consultancies. He has published 58 papers to international conference. He has done 49 conference proceedings. He has done 31 research, and he has 3 patents. Dear participants, he has published 5 books and he has received 8 awards. So dear participants, I'm impressed as gone through this amazing resume. Now dear participants, without taking much time, I would like to invite our today's speaker, Dr. Iqbal sir, to deliver his expert talk on emerging technologies in engineering. Now sir, the platform is yours. Please sir, address our conference. Dr. Iqbal sir, please.
Yeah. Thank you, Mr. Fazal Lawande. Thank you very much. Very good morning. Actually, no, in Indonesia it's afternoon already, but there in India, morning already. So very good morning to everyone. First of all, I would like to thank you, the committee of the ICT Conference 2026, for inviting me and give me opportunity to deliver my speech today. And also special thanks for my best friend there, Dr. Laxman Abang, giving me this opportunity. Thank you very much. I also would like to extend my gratitude to Dr. Vijay Rasi. Thank you, the chairman of the conference. And today, I would like to share my topic. I screen. I want to share screen first. Okay.
Yes.
Can you see my slide?
Yes, sir.
Everyone, okay. You can see my slide, very clear, engineering in medical product and process. So this is the topic that I would like to discuss today regarding the contribution of engineering in medical product and process. First of all, I would like to introduce, thank you, Mr. MC, Master of Ceremony, have introduced myself. So I graduate from Indonesia and Malaysia, and then I have some experience in working in university, also in the industry. Now I'm working for Syiah Kuala University in Indonesia. I have some experience actually in robotic and also manufacturing since time that I much younger. Then I have also some experience in robotic, aero modeling, and also in uh, uh, energy saving eco marathon competition. So we have some experience here. We in international one of international competition in Indonesia, Mandalika 2022. My team met with a team from India, as you can see here. Very nice moment there. And so for today, regarding the topic engineering in medical product and process, I would like to start that we actually as engineer, we have contributed a lot in developing a product for daily use. For example, you own Indian car like this, Tata car, and then also pump, suitcase, hand tool, car seat. All of this product is produced by engineers that we contribute to daily human life. So actually, engineering product has been developed long time ago. So it is not in history that the first engineering product of engine developed in 1712 when James Watt developed a steam engine, and then later the steam engine used for train, car, and ship. And also for the aircraft, we have a lot of contribution engineering to contribute in developing aircraft for many purposes, including military, civil, and also aerospace. Today, engineering product used in many function. As you can see here, implantation, for example, is a product of engineering in developing for shipment. Also in the workshop for welding, for example, and also turning process and other machining process. And then we have contributed to developing a robot for manufacturing, for aerospace, and also humanoid robot. And also, not least, the spotlight and lifestyle. You know, many equipment of lifestyle like fishing equipment, cycling, sport like tennis sport. The equipment is developed by engineers, and we know that human actually they like to spend a lot of money to buy this equipment of lifestyle. So we can imagine without engineers, the world that we live today is not actually like this. And then what about in medical? This is the topic that I would like to talk today. In medical, very much different. The medical is a field of study as well, similar to engineering, but medical engineering is very much different, especially in the object that we handle. In medical, the medical person, the expert, will handle human or animals, meaning that it is living thing. Living thing is a very hard to control, different to the object of in engineering. In engineering, we handle non-living thing. We handle materials, we handle equipment, tools, machines, and even our product is not a living thing. So, however, in medical, you can see this example. in medical, they need some equipment that this equipment developed by engineers. Yeah? This example in dentistry, for example, they need to make a hole in the tooth of the patient. And this equipment actually is very much similar to equipment that we use in our workshop. But of course, different speed, different condition, and also different size. But the basic of this equipment are similar. So we could say here actually this product that used by for medical purpose is similar to the product that produced for workshop purpose or manufacturing purpose. The other example is a passing door. Passing door is one of the equipment that required in surgery room. You know, in surgery room, the doctors will provide some surgery activity. Then they need to sterilize all of the equipment, all of the tools. Even the doctors themselves, they have to be sterilized before they start working in surgery room, because they have to protect the patient for contaminating and infection. So, however, during the process of surgery, the doctors require some additional equipment from outside the room. So when they need this equipment to pass to the surgery room, the equipment should go through this passing door. So the passing door, they will put the equipment there, and then they close. This passing door actually got two doors, the outside one and the inside one. So when they put the equipment inside this passing door, the process of sterilization start. When the equipment fully sterilized, and then the doctors will open the door inside the surgery room and then take the equipment. This actually the requirement of the medical, but however, this product passing door is produced by engineers, because some temperature is required, some pressure, and even some spray of chemical substance to sterilize the equipment or the object inside. So in this case, we can see that actually how engineers working together with medical, and how engineers serve the requirement of the medical process and medical equipment. Another example is a patient bed. This is the bed that used by the patient in hospital. You can see here, this equipment actually consists of wheels, spring, link, joint, ankle. All of these equipment are produced by engineers. It's an engineering product and used for medical purpose. Also in orthopedic, when the patient got some bone broken, they need to be cared by an orthopedic doctor. And equipment used here is also called is an engineering product. Also for ultrasonography and another sensors. I will check my sound. Are everybody hearing my voice clearly? Hello? Hello? Is it clear?
Yes, sir.
Okay.
Yes, sir.
Okay.
Yes, sir.
The slide is clear, eh? The slide
Yes,
is
sir.
clear. Yes. Okay. And we continue.
Yes, sir.
So I would like to share some of experience of our co-researcher. This is Dr. Fitra. Dr. Fitra is a doctor of brain surgery, my very close friend in my university. He shared with me some experience, and then we help him in doing this surgery. So this is the case when the patient got some very serious accident. This accident actually caused the patient got some piece of wood inside his head. You can imagine the piece of wood inside the head because of the accident. This is a very serious one. Of course, the doctor need to take out this piece of wood from the head of the patient, but they have to be very careful how to take out this piece of wood, because if they do some mistake, when they take out the wood, and it can cut some of nerve, and then the effect will be very total for the patient. It could be dead immediately. So they have to be very careful, and they have to be discussed how to take out this piece of wood from the head of the patient. All they have is only the scan, the picture scan of the patient. This one is the, as you can see, this three picture. This one is the product of CT scan. But this CT scan actually is only 2D, 2D pictures. And they want to have a real object. Then what they do, so with our help in our lab, we convert these CT scan pictures into CAD file. Then when we have CAD file, and then we convert it to STL file, then we use this STL file to print it in 3D printing machine. And after we print it, we have this one. This is the model of the head of the patient. As you can see here, the brown one, this is the location of the piece of wood inside the head because of the accident. Yeah, and this red one is the nerve, and the blue one is also the nerve. So using this model, the doctors could discuss how to take out the wood from the head. Then they can do some simulation, they can do some practice until they satisfied, they have decided how to take out this wood, then they go to the surgery room. So you can see how this engineering work, converting the file from CT scan file to 3D printing, and then we print it in 3D printing, and the doctors use the model. And then finally, the doctor do the surgery, and they can save the life of this patient. Hello, is it clear? Hello, everyone.
Show my screen.
How is my voice?
Yes, sir.
Yeah, clear, eh?
Yes, sir.
Yes, sir.
We can hear you.
Slide?
Yes, sir. No, sir.
You can see the slide. You can see the slide. Can you see the slide?
No, sir.
No slides.
Only your screen is showing, sir, but slide is not showing slide, sir.
The slide is there, correct?
Slide problem is there, sir. Screen is showing, sir.
Oh,
Screen showing, but your slide, your data not showing, sir. Your PPT is not
Sir,
showing.
please share your entire screen. Then your presentation will be shown. It shows only Google.
okay. I'll try. Share screen.
The entire screen, sir.
Entire screen.
Yes.
Because previously share. Entire screen. Share. Can you see my screen?
Yes, sir.
Yes, sir. Now
Yeah.
sir.
Yes, sir. Yes, sir.
Okay, with 3D printing, there A, B, C, D, you can see, yeah? Can you read it?
Yes, sir.
Apriawan Fitra 2021.
Yes, sir. Brain surgery.
Okay, we continue. Okay. So another case that I would like to share with you is the case of the other patient. Yeah. This is also the patient of my my colleague, Dr. Fitra here. This is the name of the patient, Eva Paradila Yusnia M. Ali. They have the same cases. Yeah, they got traffic accident, and because of this traffic accident, they got their head skull broken. As you can see here, the broken is this, the location of the broken skull, This one also the location of the broken skull. So handling this problem, usually doctor use material to replace the bone because of this accident. The bone totally broken, then they cannot reconstruct it. So they need to make artificial bone. There is some material they use called as acrylic cement bone. This acrylic cement bone is very familiar in brain surgery doctor because this material actually can replace the bone. Yeah? It is consists of two substance of material, the powder one and the liquid one. So when they mix this powder and liquid together, after 10 minutes, it is curing. It's cured and then it's become hard, like exactly like a bone. So what they do in this patient, this one they will put some casa film there, and then they will put this mix of acrylic cement bone to replace this hole. But then after 10 minutes, they got some material that replace the real one of the bone. But the problem is the bone is there, but the shape of the bone is not the same as the shape of the skull of the head. So mean the acrylic cement bone cannot replace this curve. So the shape is flat. So you can imagine if you can survive the surgery, but after that you have a flat head. Of course, nobody like flat head. They want the original form of the head return after the surgery. So the idea is the doctors asked me to provide some mold, some mold. That this mold can be used as mold to make the acrylic cement bone or the artificial bone. Then we try to help the doctor. What we do actually from this file, this one is the product of so-called CT scan. Then we convert the file of this CT scan into STL file. STL file is the file for 3D printing. Then we make the mold for this broken bone. Exactly that this form. We make the mold using 3D printing. Once we have the mold, the file, and then we print it in 3D printing, and then we have this mold. So this mold actually, the form of this mold exactly like the broken bone of the patient. Yeah. And then doctor use this mold, they put the acrylic cement bone inside the mold, and then they wait until for at least 10 to 15 minutes for the curing process. After 15 minutes, we have an acrylic cement bone with the form exactly the form like the patient bone, and then continue with the surgery. Okay, so this is the surgery process. Then we put it in these two patients. The other, actually, we have replaced, we have repeat this process for the other two patients. So our group got 3 patients that use this mold for acrylic cement bone. This one a little bit different compared to the first one, because the first one we have only one mold, one side. Here we got 2 sides of the mold. This is acrylic cement bone, and then inside the mold, and then we put the other mold there, and then we have this product. This one, the acrylic cement bone, this one will replace the real bone at the position of the head of the patient. So until today, we have 3 patients that use our product. This is my group of research. This is Dr. Fitra, medical doctor. This is myself and my student. So you can see here how engineers and medical doctor work together in order to make this medical product more efficient. Okay, and the other contribution that we can contribute to the medical as an engineer is we can develop the teaching model for the doctors or in medical education. This is one of the example that we have developed in our lab, the product using 3D printing for backbone, and then all of the component of the backbone, also for the head school, and then for this one is for the teeth for the dentistry. Previously, the medical student they have to buy this model very expensive. But now with this new technology of 3D printing, we can produce this one, and with the cost is very cheap, much more cheaper compared to the previous one. And the other model that we want to develop actually is the model for the surgery. Another example where that we develop in our lab is for ankle foot orthosis. Ankle foot orthosis is used to support the foot of the patient that got some weakness of the foot. So the foot need to be supported using this equipment. Without this equipment, the foot will be they lost the power. So we develop this one using 3D printing as well. First of all, we need to check the strength, because this product actually will support some weight of the foot of the patient. So we need to make sure that it is strong enough to support the load. So what we do actually, we print the material is from PLA, then we print the material, and then we provide some mechanical testing, tensile test, and also bending test. One, we have the data from this tensile and bending test. We got the data of the mechanical properties of the material, and we use these properties to do some strength, to analyze the strength of the product using finite element method. Finite element method, we need to enter some data regarding the strength of the material. So we got this finite element proving that this product actually is strong enough to support the load. This is the result of the study. We put the load of 50 kg because we have some data that the maximum weight of 1 foot of human is 50 kg. So based on mechanical testing, we got this data that the density of the material 3D printing PLA is 1.066 kg per meter cube, and the young modulus is this one 2,228.69, Poisson ratio 0.32, and then based on this data we enter into the valid element software, and then also this load, and then we got this result. As we can see here, the total load is much lower compared to the strength of the material. So this one, 5 MPa. This is actually proof that the product is strong enough to receive this 50 kg of the load. Then we print the product size and also the form, exactly the model that we have modeled in valid element, and we got this product. And then now this product are ready to be used by the patient. Another product that we have developed in our lab is a prosthetic foot, different to orthosis. Prosthetic is to replace part of the body that loose. For example, patient that need to get some amputation of the foot because of it could be because of the accident or because of diabetes and other. So when the doctor provides some amputation, now the patient lost the foot. Then we need to replace the foot with the prosthetic. The prosthetic foot that we have developed also using the 3D printing product, PLA. Excuse me. Okay, we continue. This is the prosthetic foot. The study that we provide for this prosthetic foot is similar to the orthosis one. We make the material first. Oh, this is not from 3D printing. The material is from composite. We use natural composite, abaca or banana composite as the material for this prosthetic foot. First, we start with developing the material, and then we provide some mechanical testing. This here is the tensile test to get the data. This data then will be used for finite element modeling, and we test the load. So the result that we have is this one. This prosthetic foot able to receive 100 kg of the load. Then we make the prototype. So the prototype we make using press molding method. Press molding method of the composite require the mold, and the mold we make the mold using 3D printing machine. The material is the PLA. So this is the process of developing the mold. Printing using 3D printing. This is the mold, and then we start the process. We put the fiber, we put the matrix. In this case, is the epoxy matrix, and then we press the mold because the process is press molding process. And after curing process of 8 hours, we can take out the product from the mold. This is the product that we have later. And then we need to put some connection here. Then later we have product like this. Yeah. However, we didn't test it to the real patient yet for this product. So this is only the result or the strength analysis of the product provided only in the lab until today. But this year, actually, we want to continue this research, and then we want to add some connector here, and then we want to test in the real environment, meaning that we want to provide some tests directly to the patient. Patient will use this prosthetic, and then we want to get feedback from the patient regarding the stability, regarding the safety, and also how they feel when they use this prosthetic foot. Okay. Then with that, I was informed that I given time of 25 minutes for this speech. Now I already used all of this 25 minutes. Then with that, I would like to end my presentation. So as a conclusion, actually, I would like to remind everyone that actually as engineers, we have a lot of opportunity to contribute to medical. So if we today, if we read a lot of publication of engineering, still a lot of engineers focus on engineering product. We develop car, we develop machine tool, equipment, but you need to expand your field, the object of your research. You are still doing research in engineering, but you object, then you can sweep your object or expand your object to medical. So a lot of problem that the doctors need to be served by engineers. They have a problem, but they don't know how to solve the problem. So I just start this actually for the last 3 years. But then I found that many problems that doctors cannot solve for long time, and they think it is a very difficult problem to be solved. But then when they discuss with us as engineer, actually it's very simple problem. Then we can solve it very simple way. Then we can contribute to medical in very efficient way. So with that, I would like to end my presentation. Hopefully after this, a lot of engineers, the participant of this conference will start to contribute to medical product and medical processes. So thank you very much. Maybe if the message MC, Master of Ceremony, if you have some question and answer session, I am happy to discuss. Thank you. Thank you very much.
Thank you, sir. Thank you very much. Any question from participants?
Thank you, sir.
Any question from participants? Am I audible? Any question from participants? Hello, participants. Any question? Okay,
No,
thank you. Okay.
sir.
Okay.
Yeah, if you have any
No,
further
sir.
question, I have my email there in the slide presentation, so you can contact me through the email, and then maybe we can develop some collaboration research, a very simple one, but we can start with some also called collaboration, and then we can publish together, and maybe we can supervise.
Thank you, sir. Thank you very much, Dr. Iqbal, sir, for such an insightful and inspiring talk. Your valuable perspectives on emerging technologies have understanding and motivated us to explore new possibilities in engineering. On the behalf of our institute and everyone present here, I would like to express our sincere gratitude to for sharing your knowledge with us. Thank you, sir. Now, thank you all international. Yes, thank you, sir. Thank you all international and national advisory committee members, our principals, Dr. Vyarati, sir, for giving your valuable time for this inauguration. Now I conclude this inauguration. Thank you, everyone. Now I request to all the participants, please join respective department-wise links. Very soon, our respective coordinators will give you that links. Thank you, sir. Thank you very much.
Thank you, sir. You are present nicely.
Thank you, Dr. Aban. Thank you very much.
Yeah.
Welcome.
When will come in India?
I will. I will.
Okay. Okay. Welcome, sir. Welcome. Yeah. Thank you, sir. Thank you for sharing your spare time. Knowledge is also huge. You have done huge work in medical sector.
Yes.
We'll call you next year in India physically.
Yeah.
Welcome. Thank you, sir. We'll move the next session. Thank you, sir. A good
Is it
day.
finished now? Can I?
Yeah. Yes, sir. Yes, sir.
Yes,
Exit,
sir.
huh?
Please, sir.
Yes, sir.
I log out from the conference, huh?
Yeah.
Okay. Thank you, Dr.
Thank you.
Aban. Thank you, Mr. Lavande.
Yes, thank you, sir. Thank you. Welcome.
Yeah.
Thank you, everyone. Bye-bye.
I request to our departmental coordinators, please share your links